So the question is for the communication protocol, is TCP or UDP used or whatever? So it's TCP. It's a TCP connection that will, so both, either peer can originate a TCP connection, so as your node, you can either initiate the TCP connection to connect to somebody, or somebody can initiate the TCP connection to connect to you. And then there's a handshake to exchange the versions, and after that, it's all the same. Like whether you initiate it, they initiate it, doesn't really matter. It's all open TCP channels, and there you will be exchanging transaction on top of that.
And another question regarding the mining, I suspect there is, just curiosity, there is a mathematical proof that there is a solution to that problem, right? Finding that hash.
So the question is there a mathematical proof that there is a solution to that problem? That I'm not sure actually, but I think there's enough entropy in the header, in the value that are in the header, that I'm pretty sure to find a solution. You can drop a transaction too, or things like that. So there's a lot of things that you can do. I'm not sure there's an actual. That's a good question actually. I'd be interested to see if there was an actual mathematical proof to be sure that there's a solution for every single one of them. What I know is that there's no solution if you have only a nonce, like that 32 bits integer, and so you need additional entropy. The good question would be probably is it enough entropy? My suspicion would be that there's probably a tiny little edge case that's going to happen maybe once time the number of molecules in the universe, atoms in the universe, or something like that. It may not be found, but practically it's not a problem. Yeah, over there.
What's been the longest time for a block to get formed?
What's been the longest time for a block to get formed? So I haven't done statistics on it, and the problem is that the block time, as I was saying, is unreliable. So it's hard to kind of mine the whole blockchain. You would have to have data from the beginning. But I've seen block for more than an hour pretty commonly. Like an hour more blocks probably happens, I don't know, I would say about 2, 3, maybe 4 times a week. So my guess would be that the longest error is probably close to 2 hours. There's actually, so the name doesn't come back to me. Maybe one of you will know. There's a blog that's made by a statistician who's running like Monte Carlo simulations and stuff like that on like even the different parameters of the Bitcoin blockchain. And he's been like graphing probability distributions of finding a block and stuff like that. So we can probably find it directly from there, given the probability distribution that at a given space, what's the probability of finding it?
Dave Hudson of Pure Nova?
Yes, I think so. Yeah.
Dave Hudson, Pure Nova.
Yeah, Pure Nova. Yeah. Yes.
What's the best way to handle lots of microtransactions?
So what's the best way to handle lots of microtransactions? From which standpoint? I guess what's the difficulty? what's your
So I want to say many transactions of only like under 10 cents. Under 10 cents.
So okay, so instead of the best way, I'll probably talk about the difficulties of it, and then we can put so it depends which difficulty you're worried about. So are you worried about fees?
Yes.
Okay. So for fees, I'm not sure a lot of people talked about fees. Fees are pretty difficult subjects on, like surprisingly difficult subject on Bitcoin and any single cryptocurrency. And they're surprisingly difficult subject because they're one of the main ways to protect the network against denial of service attacks. Simple argument is that if transactions are free, then you can just flood the network with free transactions. And the network is flooded, nobody can use it. So fees are used as a way to prevent flooding, so that if I try to flood the network and issue thousands of transactions, then it will cost me money. And at some point, like flooding the network might be a fun game, but nobody really benefits, and I'm not going to benefit much from it. So why would I spend all that money flooding it? So that's the main fee argument. So fees have been enforced since kind of the beginning. The algorithm has changed a little bit, I think since 0.9. But that's only impacting the wallet, I think. It doesn't impact the network. And so the idea for fees is to allow some transactions that have no fees as long as their the output they're trying to spend is old enough and they're transacting isn't enough money. Right? So the idea is again that if I'm spending an old output, it's not a cycle where I'm trying to like flood the network with spending again and again and again and again the same transaction. So I'm not making a chain or like a graph, but we're spending the same things because it's fairly old. And then if the value of the transaction is fairly old, it's fairly high, there's more money that's been transacted, and so it's again not really a penny attack type flooding. So that's how fees have been used. After that, fee calculation is somewhat complex, but the basis depend on transaction size. And then, depending on transaction size, you have a price per kilobyte. So you will hear things like, okay, 10,000 satoshis per kilobyte, 40,000 satoshis per kilobyte, that kind of value. And depending on what the threshold is, so if you send it as 0 for a transaction that's not supposed to have 0 because you're spending recent outputs or your transaction is low amount, then your transaction will be completely dropped by the network because it will think that you're doing a penny flooding kind of attack. But then you can minimize the transaction, or for on the other end of the spectrum, you may want to minimize the fee or maximize the fee so that it will be adopted as soon as possible by the next miner. So going back to microtransaction, basically you're getting close to penny flooding attack. Like you're in that domain where, or dust, there's that other type of transaction that the network is drop, which is called dust, is when you have a whole lot of inputs or a whole lot of outputs, or both, with very tiny amounts. So, and the network would just drop that because it's typically an attack. So in microtransaction, you end up in that domain. What you can do though with microtransaction is minimize, you can still minimize the fees, and they're still really, really cheap. So you will have a threshold at which is not economically acceptable anymore. So you can't do microtransaction of hundreds of a cent in dollar value, right? So you cannot do transaction in hundreds of a cent, but you can do transaction of half a cent, and that will still be fairly economically viable. And then, so the threshold there is 1 satoshi per byte, basically. That's a good rule of thumb. If you include fees of 1 satoshi per byte, you're really, really close to the minimum fee you can ever put on a transaction, but you're still above the threshold where a transaction will be dropped. So if you want to do microtransactions, you can do that.
Is there another?
What sort of percentage fee would it be then? As you say, what was it, half a cent? What sort of percent of fee?
So I can give you a percentage because it doesn't depend on the transacted value. It depends on the transaction size.
Yeah.
Isn't there another problem there? Like if you assume that microtransactions were to be successful, then you'd need a scalable blockchain as well.
So yeah, the other problem, as Chris mentioned, is the blockchain scalability. So that's another kind of worms.
Well, I mean, it's related though, at least.
No, it's definitely related. So blockchain scalability. So there's different ways in which the blockchain. Well, so okay, the blockchain is a computer system. Computer systems have limited memory, limited space, like disk space, limited bandwidth, limited like cost behind wire transmission and all that. So there's all kind of ways in which the blockchain is quote unquote unscalable or just too big for comfort. One is pure size. So when a blockchain gets stored on your hard drive, I think right now it's about 30 gigabyte. That's not necessarily super worrying because disk is cheap and all of that probably gets used much. The other thing is workable memory. So in memory, you need to keep a lot of shit to get that working, right? Like that whole Bitcoin full node working. You need to keep all the end spans. They need to be close by so you can find them quickly and all of that. if the unspent database get big, then they're harder to, it takes longer to find them, so you need good database and all that. The other one is bandwidth, where nowadays on the regular bandwidth, your Bitcoin core will be happy to saturate it. If you have a fair amount of connections and you're not throttling your standard Bitcoin core network, you will be happy to take pretty much the whole bandwidth. And a good chunk of CPU too. So like validating all those transactions, well, it's some work. And then sending them around, well, it's also some work. So there's that part of it, and then there's a part of block sizes. Block sizes are limited. So that's the hard limit. Block sizes are limited to 1 megabyte. And it's a hard limit. If you send a block of 1 megabyte plus 1 byte, it will get dropped, won't be propagated. So there's a limited number of transactions that you can fit in the 1 megabyte. So if you do, so Bitcoin, I think the average right now is, no, not the average. The maximum right now would be around 3 or 4 transactions per second. If we started to be in the 50 transactions per second domain, then it would really be a problem because we would basically never be able to catch up. And also, it's a problem if you start making transactions, and just because of block space, they're not gonna get confirmed. So you put your high fee, you propagate your transaction really well, you do everything that you can do to make your transaction accepted as soon as possible, but it will still take several blocks to get in just because there's backup of transaction to get into the block because of that 1 megabyte limit. So that's also being worked on. There's different propositions that act in different ways. One is simply raise the limit, which seems pretty simple. The problem is that it changes the consensus. Well, and after that, there's all kind of political war too in the Bitcoin system, where like, some people don't want to raise the limit because they want to create a market fee, a fee market. Sorry. So basically, the idea is this: there's a limited amount of space in the block, right? So who get that space? Well, the people who pay the most fee, right? So the idea is to say, well, if there's a limit, maybe it's good for the market because it creates an incentive to put more fee, and so the miners get more money, and it's good for the miners because at some point the block reward will get halved again and halved again and halved again. So maybe after all the limit is good. That's kind of one.
Well, but I guess the point is if the fees go up, then microtransactions are not allowed.
So it makes some use cases less and less possible because the fees get higher. So that's much more of a kind of community discussion, and the problem is that there's right now, and like if you have a strong opinion, you're really welcome to start being vocal about it, because there's all kind of different factions in the whole Bitcoin ecosystem and the people who influence. So you have to think that also right now, Bitcoin is very much a software monoculture, right? There's only one coin base, Bitcoin Core, that's used by probably, well, actually all the part of, over probably 99% of the network that matters in the sense of full Bitcoin nodes, not SPVs. So given that, it controls by far the consensus as being that implementation. So whatever Bitcoin Core decides to do, everyone will have to do, no matter what, otherwise it breaks the consensus. So whoever controls the Bitcoin Core code controls the Bitcoin consensus. So after that, you have people who have commit rights on that, right? And then you have all sort of other people that can submit patches, maybe the patch will be agreed, and there's again some sort of consensus around the development of it, and things that are good or bad. But then there's things like this that aren't necessarily good or bad, like which is best, right? Like Satoshi also took all kind of decisions and which one was best or not. So in the case of microtransactions, you can actually find email from Satoshi, and he said that he has nothing against them, right? Like he says that it was his full expectation that given the price, like the more low, and given the price of memory going down, disk space going down, bandwidth going down, microtransaction would become more and more viable as time goes. But again, some people just want to say, well, maybe we need to think right now about getting a real fee market and getting market economy around fee prices so that miners can have a long-term revenue. And you can say that's a good argument, because if miners don't have any revenue, then anyway, all that discussion is moot, because Bitcoin will not be secure anymore. So, like which one is which? After that, it's much more timing issue to like which one do you want to do first? Like, do you think right now making a fee market is important? Some people just want to also be able to experiment with it, right? But some people see Bitcoin as an experiment. Oh, let's experiment with that, see what happens, and then we can react to it. Some people see Bitcoin as a system that has a lot of money on it and that a lot of people are using it, and so it's not the world ground for experiment. So, yeah.
The new instruction you mentioned, I think in the last lecture, it could keep all these microtransactions off the blockchain, right?
Oh, okay. So the question is, there was an operation that I mentioned in past lecture, which would keep all the transactions off the blockchain. No, so that's just so the up return is just, it's one type of transaction that allows you to embed a little bit of data, but and it's prunable in the sense that you can sort of get it out of your blockchain. No, that's not that. Okay.
No, it's the check.
Check lock time verify. So that's not printable. So the check lock time verify is just a better way to do the lock time that we were talking about earlier. Because lock time has all kind of issues, like the one where we were talking about, where you need to kind of keep the transaction on the side. So check lock time verify is just a kind of a better way to do that, but it has no impact on blockchain scaling or printability or any of that.
No, you can do microtransactions by using that instruction and putting, basically doing a larger initial deposit.
Oh, okay, yeah. So you can do micropayment channels, yes. So, okay. So there's two types of microtransactions. There's a type of, it's a transaction and it's a small one. End of the story. It's a microtransaction. There's another type which is small increments of money. So say you're a cellular provider, right? Like anytime you're on the phone, they could charge you by that second that you're talking right now. Or they could even charge you by the volume of data that's going over the cellular network. And so like give you a base price of satoshis per byte or whatever. In that case, it's a payment between you and your provider that's repeated in small increments. So there's a protocol for that that's called payment channels. And the way it works, it's kind of, so it's off blockchain for the most part until the payment is validated. And basically you exchange a transaction between you and your payment provider, like say like T-Mobile is your phone company. So your phone will keep on exchanging a transaction with T-Mobile with increasing amounts for every single like say second you're talking. And your phone will sign it, send it back to T-Mobile. T-Mobile say, you took one more second, sign this one now. You sign that transaction, send it back to T-Mobile, say, you took one more second, sign it. And so you have that exchange going. And then after either your conversation is done, or after say 24 hours where you call 3 people, after a while, that final transaction with all the time that you sign is sent over the network. So that's a way to do microtransaction that's incremental. And because you only send that transaction between yourself and say, in my example, you're a cellular carrier, you don't create all those tiny transactions over time. It ends up being just one transaction, but it's a protocol for transaction exchange. So payment channels are a good way to do microtransaction. You will also not run into any fees or anything, but it's much narrower in the sense that it only fits that particular use case. If you have a use case of, well, any other use case that involves, like say, tipping, for example, which is a popular subject right now, tipping is definitely not that. Tipping is a whole set of people sending to a whole set of different people.
So how does that work?
Then you have to be more creative. You can't use micropayment channels, right? So you have to use a standard transaction. And then after that, you just create more transactions. So that's the whole, again, we're going back into the whole, how do you minimize fees, how that a transaction can even be economically viable at some money threshold, and then blockchain scalability, are we going to all collapse because the blockchain is bloated, all of that kind of discussion. And there's also a whole bunch of, so as the size of the blockchain goes up and the number of transactions goes up, there will be more incentive for people to kind of start like pulling, like playing with those triggers. So it's kind of a chicken and egg, right? Like well, why should I mess with code and make a change that's going to be potentially pretty complicated because everyone has to update their node all over the network, if right now it's not that bad, right? So, yep.
So, I might have this number wrong, but I thought I read that you can have 15,000 inputs and 15,000 outputs in a transaction. Is that about right?
15,000 seems too much. Your transaction will be too big. But there are like 1,000.
Okay.
I don't think you can have 1,000 input and 1,000 output. I think that will pass the size threshold. But I think you can have close to 1,000 of either ones.
So in a single transaction, could you form that transaction that whatever that maximum number of inputs and outputs is, you just kind of pooled together a bunch of requests for transactions into a single transaction? Could you take 1,000 transactions and squish them into one transaction?
Yeah, that's possible. It's more difficult than it sounds though, because each input needs to be signed.
Yeah.
So if you pull that transaction together, you're invalidating the signature for all the inputs if you use a standard signature type.
Everybody's got to sign again.
So everybody's going to sign again. Is going to have to sign again once the transaction is full. After that, I don't know if you remember, but when I was doing the talk about the scripting, there's other signature style.
Right.
Where you sign only, like say, for an input, a given input and output and whatever.
Yeah.
So that would be also possible to do a transaction like what you described.
Yeah.
Signing just your input and an output, but then it doesn't leave space for change. So it's also tricky. So it's a little complicated. And plus, the other problem is, if you build that transaction, right, sort of custom build that transaction,
Yeah.
no wallet can send those fancy transactions.
Oh.
No wallet will sign your input.
The client software sucks.
Yeah, the client software sucks. So one of my current little pet peeve on them is that, and at some point maybe we'll end up trying to do something there, but there is no way to build a transaction that's probably not the standard one that the wallet would give you, but it's still a very interesting transaction, and send it to the wallet of the person and say, can you sign this for me, please, on behalf of your user? And then the user can either get an email and say, oh, somebody sent us a transaction, do you agree with it? Yes. Or like see a pop-up or whatever.
Yeah.
So I think that's one of the domains where there's probably a standard missing there.
Yeah.
Right?
How do off-chain transactions work then for?
So off-chain transactions. Yeah, so for microtransactions and transaction scalability standpoint and all of that, a lot of people feel like they should not put their transaction on the blockchain. So probably the biggest example of that right now is Coinbase, because they have a lot of users, they have a lot of merchants. Users send money to another user, users send money to a merchant, merchants send money to a user. So, well, it's all within Coinbase, right? So why put it on blockchain? And then they can do micropayment and within their own system, so they don't need to pay the fees or anything. The problem with that is it's convenient, but it's definitely bigger centralization, right? Like, so at this point, how different is that from PayPal? What's the difference between PayPal with having a little Bitcoin